take the opportunity to welcome everyone to the August 3rd SERC talk on what were the top issues and opportunities from the SERC model.
Okay, I guess I interpreted it was 2016.
This will be presented by Dr. Mark Blackburn and Ms. Megan Clifford.
So actually, all
we have the
of
opportunity to dial in here shortly to internet connection issues. So again, just so everybody knows, today's session will be recorded and the archive will be available on our SERC website. For those not speaking, I ask that you locally mute yourselves. That way we don't get a lot of feedback on the phones. For questions and answers, we prefer that as we're going along, if you could use the chat box on the WebEx screen to enter your questions, and we will address those questions during the last 10 to 15 minutes of the presentation. And of course, if there are any issues or if you have any comments regarding today's presentation, you could always email us, either myself or Mimi Marcus or Megan directly, or just email us at info@sercuarc.org and we will address any questions or concerns. Again, that's not in real time though, so if anything immediate, please utilize the chat window. With that, I would like to turn the floor over to Dr. Blackburn and Ms. Clifford to introduce themselves fairly quickly and then go off into the presentation.
Okay, yeah, this is Mark Blackburn. So I joined Stevens in 2011, and I've done a number of different, I've been a principal investigator on a number of SERC research tasks, even one that actually sort of relates to why we're actually having this conversation today.
I'm Megan Clifford, and I also work with the SERC, and I'm principal investigator and research engineer on a couple of different tasks as well, and I'm very interested in the model-centric engineering and implementing that.
Okay, so why did we actually have this forum? It turns out that one of the tasks that I have been involved in, which was for NAVAIR, which is NAVAIR is a part of the the Navy that actually designs the aircraft vehicles, was they asked a question about the feasibility of transforming the way that they actually do engineering, and this was back as long as September of 2013. And so they asked us to investigate the technical feasibility to actually use computer or digital models that, and replace the way that they currently do things. And so about 2 years later at one of the SERC reviews, it was brought up by a number of people that maybe we should actually have a forum like this and bring people together. And so our research really showed that model-centric engineering, which is, we named it that because we first started with model-based systems engineering. Other people call it model-based systems engineering, and there's no exact definition for it, but we actually use the term that it's basically involves diverse model types with simulations, surrogates, systems, components at various levels of abstraction fidelity across the system and lifecycle boundaries, and that is much more involved all the way from mission area analysis all the way to systems to even like modeling and simulation of manufacturability. So, and why has it actually emerged? And that is because the computational technologies underneath them are advancing. We actually had about 30 discussions with industry, government, academia, found out that the engineering practices are evolving and there's significant adoption. And so that's how we actually got started here. However, that said, even though the technologies are there, which was one of our key research question, there are still other challenges that are related to technologies too, but also business and acquisition. And so one of the key things we wanted to do is to bring people together from government, industry, and academia to look at some of these challenge areas. And we looked at it from both a business and cultural and technological point of view. So that's what we're going to talk about today. Next slide, please. So we actually sent out a flyer. It was by invitation only. We envisioned that we would probably invite about 75 people and get about 50 to 60. We got all 75 people to come, and they pretty much showed up and stayed for the entire day. So that was viewed, I guess, as a positive. The thing is that we did want to have that balance. So, you know, we had basically 15 of academia. A lot of the academic people like me were actually involved in actually documenting what actually occurred. We had 25 very senior level people from government and about 35 from industry. The key thing was to actually have an open discussion so that we could actually talk about some of the actual shortfalls or some of the key challenge areas. Next slide, please. Thank you. All right, just so you know, so we're on slide 5, in case people are actually not on the webinar. All right, so this is the agenda, and for the most part, what we're going to do is we're going to talk through each part of the agenda. The meeting was actually kicked off by Dr. Dinesh Verma, who was actually supposed to give this talk today, but he's not here. And Ms. Philomena Zimmerman, we called her Phil. Everybody that knows her calls her Phil. And they were actually the two sides from both the SERC and academia side and from the government side that sort of set up and coordinated everything that was going to be happening on this event. And then Ms. Kristen Baldwin came in and she actually gave some opening remarks and posed a number of challenges, such as she could envision basically a community where we seamlessly exchange information, perform the analyses, and make decisions based on models, much more models, knowing that we were doing it so much. And when she says models, she basically means the data, algorithms, and processes, and any kind of hybrids. And that's why we actually adopt even the model-centric word to it, which is that we also see that if you have models or algorithms or other types of things, sometimes you're going to actually integrate in, yes, simulations of the models, but also potentially existing components as surrogates. So that's where the model-centric word sort of came from. And so, and when we actually couple that with the computational power that is continuing to emerge in terms of even high-performance computing, supercomputing that is available, that has really changed the entire, way that we can actually do work. And so their organization, basically the Deputy Assistant Secretary of Navy, DASN, which is what Ms. Baldwin actually runs, they actually use the word digital engineering. And so those terms, we're treating them sort of synonymously at this point. So our focus was on, talking about methods, processes, tools, but also potentially cultural changes and things that are really socio-technical types of things. And at the end, there's a link to a report that gives much more detail into what we're going to talk about briefly here today. So let's go on to the next, and I'll basically fill you out on the agenda, which is what we see here as we go through the charts. So there was some contextual talks to set the perspectives. One was given by Dave Cohen, who's my sponsor at NavAir. He basically talked about it from why the government needs a transformation. We also had Mr. Aaron Copeland, who spoke on behalf of industry and gave a different perspective, which was like why industry wants a perspective. And for some of you might be interested, industry actually created a white paper, the AIA, Aerospace Industry Association. They actually, a number of different industry people came together, and they actually write a report about earlier adoption of it, and one of the kinds of things are reflected in there. We'll discuss a little bit later here too today. And then we also had Mr. David Richards actually from the Engineered Resilience Project, okay, and he actually spoke for Dr. Jeff Holland. Now Dave Cohen, he actually came in from a very high-level perspective and actually talked about why they want to do it, and this dates back to like some of the key things that we were talking about, which is the new challenges and actually getting capabilities out to the warfighter faster is really critical. And so he started at the mission level kinds of perspectives and talked about what he calls kill chain analysis, which is, you can think about that as trade-off space in terms of how I would bring actually capabilities together to try to address some of those types of changes. And the need to actually figure out what he called the small sacred set of requirements and the concepts, and that would lead to the detailed requirements, but doing them more in the aspects of models. Well, Mr. Copeland, he actually talked about it from their perspective, which is that he reflected on the fact that Northrop Grumman has some model-centric engineering efforts in place, and they plan to roll them out, more in other areas, and that's because they're seeing the demand and actually the response from it. But he also talks about that there's a number of challenges which were repeated throughout the day, and we'll summarize those later, which is there's a lack of operational, standard architectures. We have a large set of standards, but maybe we need a smaller set. There's so many. And then there's also what's helped them a lot is the ability to trade space and to actually leverage more high fidelity models. But knowing how to do that is pretty critical. And that blends in with the talk by Dave Richards, because that is exactly what they actually do at Engineered Resilient Systems. They actually are leveraging what's called the High Performance Computer Modernization Program. It really deals with using high performance computing and an associated set of capabilities that are referred to as the CREATE platform. They have them for basically air vehicles or ground vehicles. CREATE stands for the Computational Research Engineering Acquisition Tool Environment. And what was very interesting about his talk is how they have used these high-performance capabilities integrated in visualizations. They actually usually give an entire track of talks at NDIA. So if you're going to go see that in October, they're probably going to do that again. But what they've been able to do is to do trade space analysis where instead of in the tens or even hundreds, they're actually able to look at millions of designs. And this includes multi-physics based models. And when they do that, they end up are able to look at it to actually buy down risk. But their other associated interest is in the notion of resiliency. So and what they mean there is that they want to be able to understand a particular design that when deployed will be resilient to allow it to be adapted in the future to things that were not planned at all. Okay, next slide, please. Okay, we're up to slide number 7 now. All right, then we followed up with a panel, okay, and we brought in, we ended up having Dave Cohen. He joined us again, but we brought in a number of different people, and I'll actually go through each of them in order and talk about it. But what was interesting is the way that they got lined up, which I guess was by Mr. Robert Gold, who actually works for Kristen Baldwin. He's the director of the engineering enterprise for DASD. It ended up starting with the mission level perspective, moving into like digital systems kinds of things, to actually the systems types of things, down to manufacturing and production. And then we heard a good story at the end about a change from NavAir or NavC that is actually using some product data model, and there's a different form of collaboration going on. So we'll talk about each one of those. So Dave carried on his talk from what he had talked about before, but actually to put it in the context of what's called the lead system integrator, and that is actually the function that is actually performed by NavAir. And so they need to leverage the capabilities to be able to do more effective mission and systems analysis, but to get things, rapidly deployed. And as we speak here, since we actually even documented this, there are some new initiatives actually rolling out where NavAir is beginning to talk to industry about different ways of actually doing work, much more collaborative. So the idea is that for the acquisition organizations to basically to use or foster the actual use of digital technologies so that they can actually continuously work with the contractors to basically come up with a design in a more collaborative way. And so even talking about things such as removing the traditional type of monolithic reviews, which are typically the SRR, system function review, PDR, CDR, thinking about a more event-driven kind of an approach. Then Colonel Kelly Tucker from the U.S. Air Force, he actually built on some of Dave's discussions and talked about the concept of called a digital threads, and which actually is a way to actually look at threads of computation cutting through the entire system, and also a digital twin, which would be, for example, the twin for a particular aircraft, the tail, would actually be a digital characterization of everything related to that. So you could think about how that would be so powerful in future parts of the life cycle for being able to have greater detail about not only the system of as designed, but also as built and as configured to support sustainment and operations. And so But he also talked about, how we're going to do this, because there are a number of challenges currently, and some of the things that are of concern, for example, includes what are the right, data rights for government, and what about protecting the intellectual property? So that actually, there was a number of conversations about that. It's like we can see that it's like the government doesn't necessarily want to take, or at least in some of these kind of situations, really want to take the intellectual property rights away from contractors, but they certainly want to be involved, say, quote, inside the loop, if you will, of trying to understanding from a digital perspective or from a model perspective, evidence that shows that the design is maturing and is actually going to be producible and will actually provide value all the way back to the mission level. So we're trying to think about keeping mission level information connected digitally all the way through systems, and then actually having some assurance that it's actually manufacturable and producible. And we did actually hear a number of talks about actually even modeling and simulation in the manufacturing space to actually do trade-offs really early on, considering those types of things, the way it would be built. Okay, next slide, please. Okay, so we're up to 8, and continuing on the panel, we also had Mark Signorelli. He is from BAE Systems. They do combat vehicles, and he ironically actually talked about a point where he said that they were actually using models on small teams back in the 90s, and he said it was in some ways very effective. But he also talked about a number of the challenges, and so some of those kinds of things involved changing the mindset. Sometimes maybe the acquisition organizations these days are they're buying all the digital data, but they're doing that just because that's all they know how to do. And there's an enormous amount, or at least some cases here, potentially an audit mindset of auditing the kinds of things rather than trying to deeply understand the information in the models. So that would be important. The model environments, they can drive down the number of requirements, but that's because they're actually describing it in more rigorous and detailed terms in different kind of views, and that backs up Dave Cohen's idea of believing that there's a high level of requirements. And what he even has talked about is sometimes is that all requirements are tradable, and in some ways when you're looking at the models, they maybe it's more constraint oriented than actually, quote, pure requirements. Another important thing is that in the modeling environments themselves, better than data, they can actually begin to capture knowledge in the sense of you'll have representations of, say, reference architectures, designs, architectural patterns, and again, this is building on a community out there that is for example, in COSI, that is actually doing these modeling patterns, and therefore we're bringing these things to bear much earlier on. They'll have the corresponding methods that'll be associated with it, and so therefore we'll be able to understand, what is being said in there. And so, while the numbers of requirements, is actually increasing and all the details, a lot of this really exceeds the human, ability to comprehend everything, especially since most of the systems that we're talking about cut across many domains. If, for example, if you think about an air vehicle system, it has, the airframe, propulsion, the structural aspects of it, to communications, to all these various types of things. And so that's another thing that we will actually see being able to pull together. But he also concluded or closed with the fact that there are some cultural challenges. In some ways, he thought he viewed the possible adoption perspective from some people back as early as in the 90s was better than it is today. So some people aren't really interested in it. Mr. Don Kennard from Lockheed Martin, he came in and he talked about some things that were really different kinds of things that were occurred. He was involved in both the F-22 program, and he said now that you look at some of the newer technologies for the F-35, that there's all these different techniques that are in some ways very leveraging models and visualization. He gave some examples such as, assembly using projection devices. So in other words, you'll see an aircraft and you can actually use those projection devices to actually see if the airplane is stressed or bent from what it was originally, using those same kinds of things, and virtual reality even for, placing rivets. And so therefore, from a manufacturability point of view, things will go much more quickly. And now we get to the last two, which is we had Mr. Paul Russo and Ms. Carla Coleman. Paul's from the U.S. Navy, and I mean, they actually work on, it's the carrier CVN 79, and where they're working with Huntington Ingalls out of Newport Beach, and their story, which I thought was quite nice, is that they actually talked about using this product data model, and they're working collaboratively together to do this, and they've addressed what they believe to be, you know, the IP rights and data rights, saying that the government owns what to build and how it's designed, but the contractor owns how it is actually built. And so Megan's going to actually provide you a little bit more on that in a little bit later, so I won't go too much into that. All right, next slide, please. So then we had 2 breakout sessions, and I'll tell you a little bit about one. One was actually led by Dr. Donna Rhodes from MIT, and the other was led by our own Dr. John Wade from Stevens. And we looked at it from 2 different points of view. We basically, there were some opening remarks that were made in each of the groups. They were selected early on by, did they have more of a, you know, do they run the business operationally? And so what's a collaborative operational model that might need to be fostered versus individuals that might actually have a deeper understanding of the technologies that would be necessary to enable things to go on. And so with those 2 things, then they actually, when we got together, then we actually, basically there's a random way that they actually broke up into different types of breakout groups, but they set the stage a little bit to begin with. So for example, in this particular group, you know, Donna said that, you know, there's differences in model-based practices versus model-centric types of practices, and so that's why we need to actually say, well, you know, just because we used to do it with documents like this, how would we do it? And we may not actually do things the same at all. And so what would be a collaborative operational paradigm, potentially a little bit the way that we talked about with the NAVC and the Huntington Ingalls, how they actually worked with the product data model. But also tools just on their own, we think about tools, that's not enough. In other words, any particular organization can use a tool and use it without very good methodological guidance, may not achieve what they want, but if they're going to use it in a particular way, they're going to need to actually explain the method in which they produce their models and perform their analysis. So therefore, that's the kind of stuff that we would see that maybe those kinds of things need to go on to a new form of contracting where we basically include, tell us about the methodological approaches that you plan to do so that we can understand your models, and you don't even have to, you know, we can actually look at your models directly. We don't even have to actually have you actually converted into any of the tooling that we might have, because that's another issue, which is that organizations like, you know, NavAir, it's like they cannot buy every tool that every contractor is going to use. So we need to actually talk about that. That's going to come from the second panel. So in both of them, they had sort of like a mirrored relationship, and they discussed capabilities, okay, opportunities, or enablers, okay, barriers and breakthroughs for an effective, and in this particular approach, to a collaboration operational model between industry and government. So this is a non-exhaustive list. In fact, the list is quite long. I'll only just hit on a few here. So from a capability, so, you know, shared understanding of model-based deliverables. Again, what I said is that we need methods about that. Standard interfaces, you know, to facilitate how we can actually share data, or maybe meta information may be shared about the actual design. And then design spaces. How can we actually know that something that's being designed all the way down in a particular program adds mission value, okay, that, or actually could cause risks to actually achieving a mission kind of capability. And so then culture, of course, is like a very important thing. So what we want to do is to switch from these monolithic types of reviews to basically have an event-driven type of review, so you could potentially review every single day, maybe not every day, but more continuously. So it's an event-driven. Once analyses are created, then people would just be in a continuous flow. And we've heard of organizations doing more of those types of things. And so then that will actually lead to, again, more robust trade space analysis and effective, you know, knowledge management, because you're actually leveraging and continuing and have a greater probability of being able to leverage these kind of models. So you'll see, so this is actually how to do it, and you notice that some of these almost like factor in as almost requirements to capabilities that need to be out there. So from an opportunities point of view, our enablers is we're going to have the right leadership to actually look at this from a life cycle cost, because we really have discussed a number of times where if we were able to have models very early on in mission analysis, and then at basically in the systems level, that we can begin to think about even the manufacturability to actually produce a project really early on, and that will actually factor in even things such as life cycle kind of costs like operations sustainments. We need to actually have the right standards. We know that there's a lot of standards out there. We also heard, and Megan will talk a little bit, it was brought up even in the tool vendor talk, which was that while there are standards out there, all the vendors can't necessarily implement all the technologies to support all the standards if they're not having any customer needs for it. So that's an opportunity. Better representation of ConOps and mission analyses. They've traditionally been maybe not as much done or still document formed, and with the enabling technologies, there are much other ways for them to be able to do it going forward. And then obviously there's the cultural thing again. They keep bringing it back up. How does collaborative decision making work? Can we actually have some kind of a trust, which is in the next the barrier area, where instead of bringing a document to the room, you bring your model to the room, and so therefore, and can you have trust with your customer that says that I know that this is my my model and it's evolving and it's a draft, but basically let's begin to talk about it even in its intermediate form where there might be a little bit less certainty about things, and we can discuss that in the context of risks. So that is actually looked at potentially right now. They viewed it the way that they categorized it, and it was looked at as a barrier. So there's these cultural aspects. A lot of people still currently actually like the status quo. And so therefore, yes, there are gaps in the workforce, and we're seeing that a lot now that NavAir wants to go forward very fast. People haven't really used very many models in the past, and maybe they're not going to actually have to build as many models for some of the things, but they certainly need to be able to understand them. That's why we need to actually go to the next one, which is that we're going to actually try to actually expose and bring the best kind of methods that we can actually talk about that actually align the processes with the data and the tools that we currently have. And then the last thing is that there's lack of funding for some of these kind of early engagements, and maybe what we need to do is to think about that in a different way, and maybe models will actually help foster, because models definitely can, during the process of developing them, can actually help you think about your test planning, your verification planning. And there's examples out there for actually considering manufacturability and sustainment that in other projects, such as the DARPA Meta project did one too. And then in Breakthrough, there's, this says early adapters. I don't know if that's a slip. It should be early adopters, but early adapters, yeah, to actually continue to change the way we currently work and actually bring case studies together so that we can provide illustrations, examples, and reference models. And why is that? Because engineers tend to actually, they're smart people. They're very smart. These organizations have very intelligent, engineers. But sometimes if they've never done it before, if you can just provide them examples, they can actually figure out how to do that. And if you provide basically curated examples, curated knowledge, they can actually do it better. So again, we're going to have to talk a little bit about, the data rights things, how we can actually deal with that, and then an open framework for a tool agnostic, again, use. And why we say tool agnostic or tool neutral is, again, because we need to be able to share information, but again, organizations like NavAir, they can't buy every single tool. So if we have some of these kind of challenges, we're going to have to do some things and so there's opportunities here. So that's actually one of our research tasks actually for NavAir going forward is how can we actually do a little bit more of that. And then basically, we have to develop a way to actually provide new thinking about how we do deliverables. So in other words, we are right now thinking about how we actually change from the way they currently do document driven and basically C drills, contract data requirements lists for data item deliverables, and thinking about those in providing digital artifacts. So next slide. So that sort of leads into the next slide, which is the second breakout group. And again, this one actually talked about, okay, the first one was about what's the operational paradigm for change. This one is like, well, what capabilities would we actually need? More of the technical aspects for doing that. So some of the capabilities that were talked about, and again, we had 4 breakout sessions, and there was a lot of overlap. So it seemed to us that a lot of the people that were involved here understand some of these kinds of things. So one, we've been talking about, people have used the word single logical model, single source of truth, authoritative, digital model, single source of technical truth. The idea is that, is it really one data model? It doesn't actually have to be physically one thing. It could actually be a logical single source of truth that's actually digitally connected, but hopefully in a more semantically precise way, not just static links or basically semantic list links, but richer links to actually link information across the domain. And so, for example, the example that I was briefly talking about before is that what we want to be able to do is that if we have a particular airframe that actually we believe is basically has the representation to actually meet certain types of goals, which is like, speed, acceleration, range. But then if we find out that, for example, it can't actually be built with the weight that's expected, and so if we added new stresses to it, how would the angle of attack be if it had weapons on it? And so if we had to change the shape, what does that do to like the visibility that the sensors have? So we need to be able to link information across domains, and so that's what the bottom one is talking about there, which is we need to be able to do that in a much more precise way. And so some of that information might be, all in one single source of truth, but it might not. For example, engines might be built by one company, and the actual, frame is built by someone else. But what we need to do is we need to understand the relationships and effects between all those kinds of things. And so that would support, what we think is with new types of standardized verification and validations approach, and actually being able to go from, again, from a document-centered way to an event-driven, evidence-based approach to looking at maturing models. And so there's many opportunities in the areas of tools and methods and ways to manage it, model variance, and trade space. There's going to be, what we'll do is that when we end up having a trade space of thousands or tens of thousands, we don't necessarily want to throw those away. We want to manage those because just because it might not be valid in today's opportunity, some kind of an optimization that we might have actually backed away with in the future with different enabling technologies might be useful. So therefore, some of the barriers again is just cultural issues. And then again, ability to say, for example, list assumptions across stakeholders, and that again is if we could actually have the enabling capabilities to link across domains, we would actually have the ability to actually potentially link assumptions by different stakeholders. And one of those things, for example, is, and I'll talk about this, is it happens, it's being talked about a lot at NAVAIR, which is that, so we have the stakeholders that might own, say, an aerospace, the actual aero domain or the propulsion domain or the structures, and they request data, Seadrills, as we talked about there, for the gold-plated solution. In other words, the most expensive thing that they could do, not because they think that they need it, but because they're actually trying to reduce the risk, they believe, because they don't know if they actually need it. So again, there's a lot of opportunities for actually linking information and being able to do analysis across domains. And then another barrier, I guess, is just, and what would we do from a program management framework? And that is that how would program managers, make decisions in a digitally enabled world? So these are still research questions. Again, from breakthroughs, clearly there's a lot of software. There's a lot of high performance computing that's going on. Even things like machine learning kind of capabilities that haven't even been brought to bear yet. But being able to understand things with a lot of the software capabilities. There was some discussion about model translators. How can we go from one domain for one set of tools to another? I mean, again, currently there's some views that there'll be an evolving approach by government and industry, and industry might be using some tools, and government might be using other tools, and there still may be a need to actually bring them in for sometime in the future, as opposed to having the shared digital view. And then, obviously, when you have so much data, we need greater visualization capabilities. Dave Richards from the ERS project talked about that being another area where they're going to continue to work because you have so much data, big data, and visualization is important. And then last thing is like, how do we actually embed the actual reference knowledge within the tools so that it's available right at the right amount, right at the right time to help users, ramp up very quickly. All right, so, and from this point forward, I will turn it over to Megan.
Thanks, Mark. So I'll be going over the panel discussion from the tool vendors' perspective, and this is actually moderated by David Long, who's the CEO of Vitech and former NCOSE president. On the panel was Dr. Dave Richards from U.S. Army URDEC, Mr. Barclay Brown from IBM, Mr. Venkat Parameshwaran from Altair, Dr. Scott Reagan from Phoenix Integration, and Mr. Don Tolley from CIM Data Incorporation. And the tool vendor panel took the opportunity to discuss the challenges and gaps in industry and government collaboration while leveraging model-centric engineering. And one challenge that was brought up was how the request for proposals actually articulate the intent. So the motivation for model-centric engineering that's actually driven by the request for proposals, how can they be worded differently in order to enable different innovations or the ability to build these adaptive models that would be an excellent step towards breaking barriers and enhancing communications across domains and disciplines. The challenge of looking at the problem as a capability-driven aspect and not just as a set, unmovable set of requirements from the beginning in order to actually look at the capability and help shape a better and more agile future for what's being delivered. And for the model-centric engineering specifications being focused on the what and the why. So not just imposing the specific tools and requirements, but actually allow the contractors and vendors to adopt and adapt the best tools so that the best, so that what is being looked at can be delivered in the best way. So one aspect, there are technical issues with model-centric engineering that must be addressed by both the vendor community and the contractor community, but there are also notable non-technical challenges that must be overcome. The cultural issues regarding how engineers work, how engineers communicate with the subject matter experts and stakeholders, and how information is passed across the contractual boundary are key inhibitors to the adoption of model-centric engineering. Likewise, as we connect the product lifecycle to make model-centric engineering a reality, information will need to span organizational boundaries, and this will result in IP issues from the customer, contractor, and the supply chain perspective. Some notable technical challenges, too, is it's unlikely for any single tool or suite to cover all facets of the multidiscipline. So there needs to be an ability to perform and share analyses across domains and disciplines. The lack of tool integration and need to go to beyond the linked data. Not one company complies with all of the standards since tool vendors are forced into specific tool-to-tool integrations. And the current proliferation of standards has contributed to market confusion on the vendor and contractor side, with insufficient alignment and adaptation. So this lack shows the need for more cross-domain systems engineering and thinking. Next slide, Mimi. There are a couple of key questions, captured insights, and participant interchange that we've captured here. There is a lot of more room to grow and more room to move upon, but there's a lot of low-hanging fruit. And so what really helped with the forum is to get all of these minds into one room and to really tackle the model-centric engineering aspect into bringing it into our practices and having it be a standard. And so some of these key questions and captured insights is that there's a need for a well-defined game plan to guide technical leaders looking to transition towards greater model centricity. What are the prerequisites? What is the best approach given the unique context of each organization? How to assess organizational readiness, and what are the generational issues? What is the technical makeup of the canonical design team in a model-centric context? that the fact that there needs to be a move from implicit design to explicit designs. We cannot change what we don't completely understand, especially without unintended consequences. So where are the low-hanging fruit that we can really start looking at and trying to understand and get a better realization upon it? Maybe during the acquisition reform, you know, what was coming out of that imposed certain requirements or certain behaviors that maybe can be changed now that we are moving more towards a different way of deliverables, or delivering deliverables, such as delivering, you know, the digital twin aspect, or delivering a model instead of a document that has 100 different appendices pointing to different, you know, aspects of a ship or of a war fighter of some sort. To understand and address the cultural changes that are there, needs to be a pragmatic narrative on why, what, and how in support of model-centric engineering, developed and delivered with impact. What is the organizational return on investment related to model-centric engineering? This is actually a question that had come up several different times. So taking a look at this and exploring what the return on investment is that's related, to have the foresight and the foreknowledge of, okay, even though I'm spending X amount now and it may be more, what's the benefit at the end of the day and with what's being delivered? You know, do you get more of a robust system that's actually better, has better agility and has better capability? And then there is a need to develop guidance on how to put model-centric engineering on a contract with sample language describing deliverables, evaluation criteria. And overall, there were 4 recurrent themes and benefits related to model-centric engineering throughout the entire day. And I've noticed with these 4, this has been coming up in several other different meetings and conferences as well. But the improved acquisition process, improved efficiency and effectiveness, improved communications, better trade space exploration, and reduced risk. And another benefit would be improved designs and resulting systems and solutions. So with the improved acquisition, accepting the digital models as deliverables, next slide, accepting the digital models as deliverables during the acquisition process as opposed to the digitized documents could improve the government's understanding of a project status and risk, as well as reduce the workload associated with generating and reviewing documents for both government and contractors. The government could use their own analysis tool to computationally validate a contractor's deliverables in a way that was not possible with documents. An example that Mark actually touched upon earlier was the integration and integrating of model-centric engineering throughout the product life cycle, the NAVC and the Huntington Ingalls Newport News shipbuilding. The two were working together to develop product data model, and the IP and data issues were addressed by agreeing that government owns what to build and how it is designed, while the contractor owns how it is built. And to address the security concerns with the PDM, the different views were created. So there was a view to customer, indirect, open full view, which is direct view into the PDM, the product data model, the indirect exchange and direct exchange for the data updates. The program called for the government and contractor to work side by side with approximately 100 requirement changes due to how it can be built, deciphering between the actual requirements and desires. So the stakeholder involvement to obtain buy-in on how to accomplish change in operation was necessary. And there's anticipated need to continually change. So for instance, another example is the future CVN 80s, which plans to include having everything digital, where the stakeholder can constantly see the evolving digital model, and the actual construction in the shipyard will be performed using the portable computers and virtual reality headsets, which is very interesting. Then the improved efficiency and effectiveness. A digital twin of the system in question can be used to expedite production activities and maintenance activities, as well as perform the what-if analyses and test the effects of operational changes. All these could result in reduced time and effort and performance of existing tasks. What information is needed should be determined early to allow early and better cost estimates. As a digital thread feeds manufacturing, if a digital twin were present, it would provide the basis of operation and sustainment and evolution. And this point was brought up in both panels and also both of the breakout sessions. And the digital twin, which is related to what Mark Blackburn was talking about earlier, which is a single source of technical truth, or single source of truth, a single authoritative representation of the system, digital system model, would contain the appropriate data rights going into a more dynamic living system model with operational data for both operations and sustainment. So the model-centric engineering should be ubiquitous, but non-intrusive, giving the ability for selected key stakeholders to be inside various decision loops with the contractors. And that feeds directly into the improved communication aspect with the better trade exploration and reduced risk. So while these digital models are already used extensively in system development, each stage of the development, as well as each specialty domain, has its own suite of modeling and analysis tools that are often incompatible. Not just trying to mash models together or trying to fit things in a piecewise manner, but instead having it more fluid and systems oriented. So it might not be easy to extract useful information from a hardware model and import it into this cost model. So as a result, translation among the various tools is time-consuming and quite error-prone. The greater model transformation across domains and disciplines could potentially improve communication among specialists as well as reduce work and errors. And while the number of requirements in a complex development program often exceeds human comprehension, the interchange between industry and government on the comprehension of the requirements can be improved through model-centric engineering. So both parties should be using model-centric engineering for designs and communications, since it is infinitely better than a document just containing numerous pages like the 100 appendices I was speaking about earlier. But all documents exist in a model somewhere. So the idea of composing and visualizing these requirements through a simulated environment may take a paradigm shift. As an example, the current decision-making process focuses on what it costs today versus what it can save tomorrow. So the complexity of today's system means we must be able to perform and share digital artifacts and analyses across these many domains and disciplines, as well as across system of systems. And then finally, the improved designs and resulting systems and solutions. Today, it is often difficult to understand the impact of a requirement or design decision until late in the development process. When test articles are built or detailed, system-specific simulations are completed and validated. Consequently, adverse consequences from an early requirement or design decision may not be recognized until late in the development process, when the cost and time to correct are substantial. Multi-scale simulation using off-the-shelf or modified models could be used to perform the detailed and extensive trade studies to identify these adverse consequences before commitment is made to requirements and or design decisions. A recurring theme that was, stated throughout the entire forum was, at the end of the day, we really need to rethink the concept of the V model. And the same goes for the current and accepted concept of a linear phased approach to acquisition. Focusing early through a small set of key or sacred requirements to embed the notion of validation and test-driven development can allow us to capture the potential of model-centric engineering. The ability to capture the knowledge in models, as Mark was pointing to earlier, referencing architectures, design and architecture patterns, and design and architecture rules, within the context of accepted ontology can bring increased efficiency. What information is needed should be determined early to allow earlier and better cost estimates, and aspects of the digital thread and digital twin should harness and capture knowledge to ensure that it does not have to be reinvented every time and is representative of what is being sought by the customer or what is being sought out for use. So looking at the V model and taking that into play, and we actually certain areas, it's actually several V models that are strung together, or a wave model, spiral model. So looking at it and seeing, do we completely break the V model? Is it more of a check-the-box checklist of, are we working through this? Or are we actually utilizing it to have these open and honest and transparent conversations with one another? So that's something that kept coming up throughout the entire day, and every single point actually in almost in every single person's talk or discussion. And we do have an area where you can actually download the final report online on the website. It is a 14-page report and has those that were in attendance as well in case you're interested. So there's the website for it. And I do believe we have sent it out to everybody as well. And then just a plug is that coming up, please save the dates. We have our 4th annual SERC Doctoral Student Forum on the 16th of November. This will be in DC, held at 20 F Street Conference Center. And then the 8th annual SERC Sponsor Research Review will be on the 17th of November. That's Thursday. And then we can open up the floor for any questions or comments. And just to make you aware, we do have 2 other SERC talks that are coming up. And those topics will be what lives at the intersection of MOSA and set-based design by Gary Whitus. That will be the 5th of October at 1 p.m. And then why is human model interactivity important to the future of model-centric systems engineering, which both tie very nicely into this, by Donna Rhodes and Adam Ross. And that will be the 7th of December. So any questions, comments, or anything for Mark or myself, please do. And anybody else that was at the forum that has anything else to add, by all means, please do so.
So thanks, Megan and Mark. This is Mitchell. Just wanted to chime in. We did have an earlier comment from Ann O'Neill where she says these are very useful insights for advantage sector exchange. Thanks us for sharing. To analogies for commercial or infrastructure sectors are at various levels of systems engineering implementation and model-centric maturity. Do you have any comment or response to that?
Mitchell, I'm sorry. Could you turn the audio off your computer or something? Because I got feedback.
I apologize. We'll try and not have the feedback going. How can you hear me now?
Yeah, but the feedback is still on.
Maybe feedback through another. But if I could ask those participants just to mute yourselves if you're not going to ask a question for right now, it may help. I'll try again slowly. It would be interesting to analogously explore this for commercial and infrastructure sectors who are at various levels of systems engineering implementation and model-centric maturity.
So do I believe that's possible? And I would say yes, it is. And even one of the things that we did was we went out and talked to the automotive industry, and I would say that even some of the aerospace people consider the automotive industry to potentially be ahead. So I do believe that that it's possible there. I've also personally worked with the medical industry and know that they use a lot of models and types of things too. So I think that it's actually occurring already.
Okay.
Agreed.
Thank you. Do we have any questions? We have got, for those who are online, we've got the chat window open if you want to ask over the chat window. And if anybody who's not online wants to chime in, we could do it just via voice. We just got a question in from Richard Wheeler. What is the relationship between model-centric engineering and model-based engineering?
Okay. What we said is that model-centric engineering we believe to be broader. The term first came to us, well actually when we went out and talked to people about model-based systems engineering, model-based engineering, and we were asking them, they said, oh, you mean model-based systems engineering or model-based engineering, or, and so we included the definition or the broader perspective that came from NASA JPL of being model-based engineering tends to be a lot about discipline-specific types of things, and where model-centric types of things tend to integrate anything else into it, and so therefore that was the broader term. Now, Dr. Donna Rhodes, I mean, she uses the word interactive model-centric systems engineering, and I mean, hers includes other things that actually improve the way that human interacts by leveraging things such as big data or visualization. So it's strictly expanding that way. And I think that it actually embraces what the Office of the Secretary of Defense talks about, Ms. Kristen Baldwin's whole organization, and that's why they're using the word digital engineering.
Okay, thank you. Any other questions from those who have called in or on the internet via WebEx?
Here's one. This is Barry. Have you looked into how this would work for competitive prototyping?
Well, only in the sense that I know that, say, for example, NavAir is actually trying to do that, and you must be having a good plug-in because next week, or on the 15th and 16th, there's an NDA, the modeling and simulation community is having a special workshop on doing exactly that, how to use digital systems model for competitive down select.
Barry, this is Phil Zimmerman. We have actually, it's actually one of the exemplars that Mr. Welby put in front of us when he challenged us to evolve this whole digital engineering framework. That doesn't answer your question, are we thinking about it? Of course we're thinking about it. Mr. Welby's thinking about it. But for anybody who's had the challenges associated with contracting for the government, you'll know that it's more than just the model. There's a number of policy guidance and laws that have to be adjusted as well. So the only reason I'm pointing all that out is that it's not outside the realm of possibilities that we would do that, but we have to consider the whole problem in order to make it work, for the Department of Defense anyway. Over.
Thank you,
sure.
Phil.
To the extent they can do that, it'll be better than the current situation.
Okay, other questions, comments? Well, we're ending just right about on time. It is almost 2 p.m. We're about a minute off. I wanted to thank all of our attendees and certainly our speakers, and I needed to also acknowledge SERC Chief Scientist Dr. Barry Bain for organizing this series of SERC talks as well. Look forward to all of the attendees rejoining us for our next SERC talk. I believe that's Gary Whitus again on October 5th. That should be a very interesting one as well, as they all are. So please do join us again. We will have all the information on our website as well as sending out the flyers and announcements. So thank you all very much.